Hello and a hearty good afternoon to all of you. So, thank you very much for waiting. I believe this is the optimal time to start the session. So, my name is Chinmoy and I will be the host for your session. So, starting with today's agenda, I'll just show you a brief intro about the plan or what we are going to do, and I'll also talk a brief about a past incident that happened a long time back, and then we'll talk about the modeling approach. Then I'll show you the numerical model. The presentation does not have the results because it will be more interesting to see them directly on the software demo. Okay. In the end, we have an exclusive offer and announcement for all of you to make. So meanwhile, if you have any questions, I'll request you to keep them reserved till the end, where we will have the Q&A session, and I'll be more than happy to answer all your questions to the best of my abilities. So just to see the background, we have all seen that the subway systems, they go quite close to urban infrastructure, because right now the spaces are limited. That is why we have to resort to tunneling. So here you can see the modeling approach can be of any type. Here we have a shield tunnel of around 6 meter diameter, progressing very close to an existing building with the foundation elements. So this building complex or tower has been imported from Midas Gen, along with the nodal reactions at the points where the columns meet or transfer the load to the raft, and then finally to the piles and to the ground. So for the loading condition for the apartment, it can be done in two ways. Either you can import the entire complex or the entire structural model into GTS from Gen and model it like the way we have shown in the right picture, or you can just simulate the same thing as we have done, or which used to be the conventional method in the past. That is, you apply the reactions on the raft and then check for the ground deformations. Now, the reactions and loads can also be applied to the raft. If nothing else, there have been instances when people have applied foundation pressures in there. Okay, so the difference is that in the absence of the building, like which acts as a long slender beam, without that you will not see the angular displacement. Whatever you will see will be a UDL, because the entire load is applied on the raft. So it is sometimes better to check if the tower is way too high, just to ensure that you get to check the angular displacement of the ground and also of the building, because it will not be the same at all directions. Okay. So for ground improvement, there are a lot of other ways of ground improvement, or you can also say that, let's say if you have a very thick shield, you can use that too for controlling the controlling the pace of tunneling. Otherwise, in some cases, you definitely need some ground improvements. So in this case, you can see what we have done is we applied a jet grouting to the left edge of the tunnel as the tunneling moves adjacent to the building. So this is basically the ground improvement we have done in here. Otherwise, for ground improvement also, ground freezing has been done, but it is a much more expensive process. So jet grouting is, I won't say jet grouting is a very cheap process, but again, compared to ground freezing, jet grouting will be a far more easier and simpler process. So in this particular session, I'll show you how to simulate the presence of jet grouting and why jet grouting is needed, or why any other ground improvement method is needed to handle these kind of issues. Now, some of you may be familiar with the collapse of a diaphragm wall during tunneling in Germany, Cologne, Germany. So what happened was that along the diaphragm wall, they were constantly dewatering the groundwater. They were reducing the groundwater level to ensure that the seepage remained to the absolute minimum. But unfortunately, one fine day, the pumps failed due to some breakage in the power connection, and due to that the water level suddenly started rising, and it led to collapse of one of the panels of the diaphragm wall, and then the entire subway in the vicinity was flooded, but that was during the construction phase, so it led to ground collapse. I'll request all of you who are not aware of this particular accident, you can always refer to Google and read more about it, that what exactly happened. Okay. Now, coming to more or less the salient features of this particular model. So basically, this is how the model looks like. So the tower is around 22 stories high. The top layer being the topsoil, that is 2 meter. Topsoil is mostly sand mixed with alluvial. Second, we have a bit more denser sand layer. Below that is the fractured chalk layer. This is where the TBM does the work. And finally, the bedrock is highly weathered sandstone with more or less poor rock qualities in terms of rocks. So the combined depth of the model will be around 43 to 45 meters. Okay, and the length of the model is 72 meters, width being 34 meters. Coming to the geometry of the foundation elements, the raft is 1 meter depth. There are total number of 73 piles, and the length of grouted area is around 42 meters along the shield, and the thickness of the grout is 1 meters. Depth of each pile is around 10 meters, and the center to center distance between the final pile and the tunnel is around 16 meters, which at its minimal point or the minima is around 12.5 meters. Now coming to the support systems, the shield is around 50 thick, and the segmental liner is around 350 So we will be using the change property option to simulate the change in property from shield to final segmental liner. Now, so after the geometry, the meshing, boundaries, and loading part. So this is the normal ground boundary condition, that is X and Y are restrained on their respective directions, and in the bottom it is a fixed support on all sides. Now we have change property option in which the mat footing sits on top of a 1 meter thick cushion layer, because remember the topsoil was kind of weak, as I have mentioned before, but we will see more about it or the geomechanical properties when I show you the numerical model. So that is why below the 1 meter raft, we have around 1 meter of cushion layer that sits on top of the dense sand, and that does the job of cushioning the load from the residential complex to the piles and finally to the ground. And for the tunnel segmental liners, the segment which were modeled as shield before, they'll be converted into segmental liners. So the construction stage planning kinds of look like this. So the first three stages are where we activate the foundation elements, the virgin ground and the tower. And henceforth from S4 till S28, it is all about the activation and deactivation of the shield tunneling elements. And in the middle somewhere we activate the jet grouting. So just to show you, I'll just play the short video how the modeling progresses. So one thing to notice here is that The jet grouting is active just before the tunneling reaches quite close to the building vicinity, because that is something we are not willing to take the risk of. Or even as a project planner or a project engineer, any random person will not be ready to willing to take the risk on these kind of materials, that the tunneling reaching quite close to the foundation elements, and then they are thinking of ground improvement. It should be done beforehand, so that by the time the tunnel or the TBM reaches the area close to the vicinity of the foundation, the ground has been stabilized and the work can progress without further hassles. So now it's time to go to the numerical model. Okay. So first of all, we open up GTS. So this is part one of the model. We will start from scratch and try to reach till here. So I just go to new and I select 3D here. First and the foremost thing, I define the grid. I change it to 2 meters and change it to user defined 100. Now everyone please take a note that when I start rebuilding the geometry ground up, some of the elements will not exactly, or the geometric pattern will not be 100% similar to the one I'm showing. So, but the entire idea is to show you how to build up a model like this. Okay. So first of all, we need to import the model or the building model. So what I do is go to the drop down menu, click on import, I'll click on Midas MXT file. So I'll import my file like this. So you can see my tower along with the foundation elements. Now the supports were given in Gen. This will not be needed in GTS. So I'm going to delete those supports for now. Okay. Now, up after this, we will import the nodal reactions for the raft. So what I do now is I'll again go to the drop down menu, click on import. I'll click on the import nodal results. So you can see the moments as well as the forces, they are all imported. So our basic import from Gen to GTS is complete. So first and the foremost thing what I prefer doing is I'll segregate all the elements from each other. So first of all, I'll just switch off the loads in the model part, or in the mesh part. You can see in the default mesh, all three are present. So I'll separate three of them. I'll right click on the mesh part and add new mesh sets. Okay, add new mesh set. Again, the same thing. So I'll name the first one as raft, second one as piles, third one as tower. So, so if I just right click on raft and add the elements, I will be able to completely separate the raft from the other parts of the model. So it's a new mesh set now. So I'll repeat the same thing for piles. Right click, include elements. So I've selected my piles, just hide it, only the tower is left. and the tower falls under the default mesh set, which is sometimes for me it is a bit problematic because I prefer giving a proper nomenclature to all the elements, which is why what I do is I'll always segregate all of them into the assigned mesh set so that it is clear for me that how I'm proceeding or how I'm moving with it. So just right click on tower and same drill, select all of them. Okay, now tower piles, raft piles. Okay, so now we'll plan on our presence of the tunnel. So I'll activate the grid and the coordinate axis. Okay, so I'll just go to circle. I'll let's say I create a circle in here. Okay, and to simulate the jet grout, I'll create a bigger arc. But this time I have to reduce the size of the grid to 1 meters. Press OK, and like this, I'll just go to create arc option. Okay, 3 point center, first point, second point, third point. Okay, like this. Then I just joined both of them by a straight line. So I'll create a straight line from top to bottom like this, and I'll connect all of them together. So what I do is I'll click on intersect, connect all of them. I delete the extra lines which I don't need, my tunnel face and my grouted face. So what I do now is I'll go to make face option. This will be my tunnel. This will be my grout curtain. Okay, like this. So before proceeding with the ground geometry, I'll just shift it to the left hand side. So what I'm going to do is click on translate. Okay, direction, this, and it can be any distance, 30, 40 meter, whatever you believe, you find fine, like this. Okay, so it can be done now, it can also be done later on. I prefer doing it later on. So now what I'll do is I'll increase the grid size. Okay, press OK, and I'll change the work plane to top view or XY. I'll hide the piles and the tower because right now I need to create two exactly two surfaces. One will be for our ground and one will be for our cushion. So, and that goes without saying that the cushion should be a bit bigger than your mat footing. So I'll just go to create rectangle. I'll go to make face, select here my cushion and then my ground. Okay, 40, 40. So this is my ground, and one more will be my cutting plane. So I'll just create one more rectangle which should be bigger than my ground. Okay, that will be my cutting plane. So our first layer was 2 meters deep, right? So what I'm gonna do is I'll go to translate, click on my cutting plane direction Z, click on copy distance -2, apply. Second layer was 8 meters deep, right? -8. And third layer was, if you just confirm the depths, let's see, 17 plus 8, 25 meters deep. So I'll click on -25. Okay, like this. Now I'll right click on geometry. I'll create two geometry sets, because when you have a lot of geometric element, it is always better to segregate them. So I'll name the second one as tunnel, and the third one as cut planes. So I'll select my cutting planes and drag them to the respective places. Okay, and these two go to my tunnel section. So if I hide this, I'm only left with the raft and the ground rectangle. I'll hide this for now. Now I'll start creating my solid. So I'll hide the ground rectangle first and also the raft mesh, my cushion. So I'll go to extrude, click on this, then click on select direction, length -1. You have to take a note on what geometry set you are saving it. So I'll press apply. It goes to the -1 depth. Similarly, my ground should be 45 meters. I'll go to -45. I'll press apply. Okay. Next, now we will shift our focus to the tunnel panels. So just to confirm, my solids here, if I just see, this -30 till +40, that is 70 meters length. So I'll hide this, activate the tunnel surface. So I'll shift it to 30 meters length first. Translate, selected direction Y, length -30. Okay. In the geometry set, you have to select tunnel. Now, I'll create a solid out of it first. Click on this direction, this Y, length 70. Okay. So if I just check on the ground solid, you can see both are of equal length. Now we also have to create the grouted solid area. So I'll hide this. My grout is here. Let's see where are my piles first. If I just go to the side view, you can see ground is quite close to the piles, which we do not want. That is why what we will do is we will try to shift it towards the left or towards the negative y direction. But before doing that, if you have the exact measurement good, or if you are just practicing this, what you can do is you can wait till you cut your tunnel solid into your segmental solids, and then proceed with the creation of the grout, which normally I follow. But let's say if this was an active project, I would have followed the direction or the length as calculated by the design engineer, or let's say it was me, then I would have done it the same way. But here we are on a demo, so I'll use the other way around. I'll hide this space for now. Okay, activate the grid, change the work plane to XZ like this, and create cutting planes for the tunnel like this. So these cutting planes, they should be bigger than your tunnel periphery. Now I'll just shift this to the starting point of the tunnel, distance -30, and I will change the geometry set to cutting planes, because this is going to be completely deleted later on. That is why. So I'll press apply. So there are multiple ways of going forward with this. Okay. So the total length is 70 meters, right? So what I can do is I'll use the first two progressions to be 2 meters, and in between I will have 22 progressions of 3 meters each, giving a total combined length of 70 meters. Okay. So I have selected my face, direction has been selected. I'll press copy distance to one time. Similarly, I'll just double click on the copied face. Distance will be 3 times will be 22. We'll see how it looks like. Okay, like this. So I'll press OK now. Hide the grid. You can see how the cutting planes look like. If you want, you can keep the initial cutting plane, or you can also delete it. I prefer deleting that. So now what you can do is we'll just cut the tunnel into various segments using the cutting planes. So I'll go to divide solid, click on this solid, then select tool surfaces, go to front view, select all of them. Okay. In the geometry set, we can select tunnel, press OK. So here you can see 2 meters length, 2 meters length, rest will be 3 meters. To double confirm, we just click on the measurement tool and take a look. 3 meters. Okay. Next, our grouting face. So our face is here. It cannot be directly close to the piles, so we'll try to shift it to the edge a bit more. So I'll click on translate, select the face. Instead of direction in GTS, there is a more easier tool called 2 points vector. Click on the bottom point there and the point, let's say here. Click on move, click on the distance. You can see it has moved here. Okay, I'll press OK. Now I just need to create a solid out of it. So I'll go to extrude, select this. If you do not if you're not confident about the length of extrusion, you can always select the point of extrusion from point A to point B. So instead of direction, I'll select point A as the base of the arc, point B till, let's say, here. Then calculate the length, 42 meters. Okay, then press. I'll save this on the geometry part because that is not part of the tunnel. So there you have it, your grouted area solid. So right now we will divide the ground solid into various soil layers or rock layers. So I just activate the cutting planes like this. Okay, I'll delete the top solid. Same option, divide solid, select your solid, choose your cutting planes, press OK. There you have it. Okay. Now, if I activate everything at once now and I go to auto connect, software will create the connection now. I'll press OK. So you can see area for my raft has been created, sorry, cushion has been created. Similarly, I hide this. You can see if I hide the tunnel sections and hide the grouting area too, you can see how the ground inside looks like. Or just to make it more clear, I can use the clipping plane option and see here, okay, that the solids are now connected. Now, our solids are connected. So the next question is how to create the connection between the existing mesh set and any new mesh that we are going to create. So for that, we have to first of all activate the piles and the raft. So I'll just hide all the solids now, activate all the raft and the raft and all the piles. Go to geometry, click on points. I'll select convert node. So any node will be converted into a point now and they will form the connection. I'll press OK. So there you can see points have been created. Now I just hide the points on the top, points on the bottom. So the top points fall under the cushion area, right? Like this. So what I'll do is I'll go to imprint point, my target face, tool object, all of the points. Okay. And direction is the direction of the shortest path line. Press OK. So even if I hide all the points, you can see the points are imprinted on the face. So when I will mesh this, you'll be able to see that. And for the bottom points, we should not be worried because those points will be taken into account when we mesh it. So our geometry conversion part is complete now. So we'll start with the meshing. Okay. I'll hide all the ground solids first. I'll only activate the tunnel, grouted, length, and the cushion. So hide the grout, go to front view. I'll go to mesh. But before that, let's check on the material properties. Since we had the model analyzed before, I'll just import all the materials from that model. Okay, all okay. Similarly, for the properties, I can just import the same thing from here. All okay. So for material, topsoil has the E modulus of 20 MPa, dry unit weight of 17.5, saturated 19, cohesion 1 kPa, friction angle 26 degrees. Next is the sand layer, which is a bit more stiffer than the topsoil. E modulus 28 MPa, C value 1, cohesion value, C value 1, 5 value 30, direct density angle 0. Then fractured chalk, E modulus will be around 120 MPa, dry unit 23.5, saturated 24.5, C value 40, 5 value 32, direct density angle 5 degree. Finally, the bedrock with a E modulus of around 450,000 kPa or 450 MPa, cohesion 75 kPa, friction angle 39 degree, and then the grout mix. I have taken the property to be elastic with the modulus of 250 MPa. And then for the piles, the properties basic concrete. You can take any grade possible, M25, M30 or M50 grade. Okay. So time to mesh the model. So I'll start with the tunnel sections first. I'll go to 3D, select size as 1, then hybrid measure, select this. Remember the tunnel section was completely in chalk area. So I'll select the property as chalk and I can just name it anything. Let's say I name it as tunnel right now. We always have the option to rename it later on. Okay. Then I mesh the grout area with the same size. Property will be chalk right now. I'll change it to grout with the change property option. So I name it as S3 grout. Okay. Then my cushion. Since the cushion is in the topsoil, I'll initially have the property as topsoil and then I'll change the property to cushion or gravel layer. Mesh size also 1. Okay. Now time for the bigger solids. My first layer, that is the S1, so I just name it as S1 topsoil. I'll change the size to 2 meters. Press apply. Second layer will be sand. I name it as S2 sand. I'll press apply. The third will be my chalk, so I'll apply chalk S3 hyphen chalk, and here we have to select the nodes from the piles, right? So I'll click on interior edge, interior points, select the points inside, Okay, consider imprinting on face, press OK, press apply. So since it is a bigger solid, it will take a few seconds. Finally, the bedrock. I'll click on the bedrock, name it as S4 bedrock, press OK. I'll change the size to 4 meters. Okay, just activate the mesh. You can see like this. So now we'll create the liner properties. I'll hide everything, hide also the grout area. Just activate the tunnel solids, go to front view. I'll go to extract. In the type, I select face like this. Go to isometric view. Select the property as field, that was 50 mm. Click on registered based on ownership. Name it as SS. Press OK. Hide this. You can see your shields have been created. Now time to rename them. So I'll go to rename, select all, first Y, name it as shield, press apply. Similarly, I'll rename the tunnel sections too. Right click, show only, same drill, select all, first priority based on Y, name it as T. So T19, then shield 19. Okay, so this part is complete now. Now we just need to activate the change property option for the jet grouting and your um, your cushion. So I'll go to static slope analysis, change property, select all. In the property section, click on grout mix, name it as grout, press apply. Similarly for the cushion, I think I mistakenly named it as topsoil, but no problem, we'll just change the name. Activate cushion, boundary sheet name cushion, press OK. I'll change the name to F2S1 cushion. So this being complete, the same drill goes for the conversion of your shield panels to final liner. Okay, so for that the same thing, click on change property. In the property, select final liner. I name it as S-1 shield 1, apply, shield 2 S2, apply, and then so on. So this part is the is kind of a bit, I would say, like labor oriented part, but the methodology is just like that. Select the place and select the particular element and change the property there. So next we define our construction stage scenario. So we just assign the boundary condition, auto boundary condition here, and name it as ground. Apply the self weight. Okay, and then we run the model. But before that, we'll define the construction stages, which I'll show you how I have defined it. So in the analysis part, we have total of 27 construction stages, starting with the virgin ground at first. Second is the foundation elements. I'll just hide the soil layers for you so it's easier for you to see. Second is the foundation elements. Third is the tower plus the load. Fourth is the start of tunneling. So first layer. So the jet grouting should take in place in advance, or it can also take place during tunneling. It is completely based on your project outlook or your project requirement or the EIA. So in this case, I have applied the jet grouting before the tunneling phase reaches here. Okay, and then henceforth. So if I just hide the grout for you now, the final liners are applied on when the tunnel face is at least 2 to 3 mesh sets ahead. That means around 6 to 9 meters ahead. So T5, when it is excavated, the final liner is activated in the third shield, and so on. So in the 24th excavation, although the excavation has almost reached the breakthrough, but the liners were not installed. So after that, we have 2 more layers where the liners are installed. And in the initial layer, we have defined the water level at minus 1.5 meter. Now, in this particular model, the jet grouting was not activated. So you will see what happens when the jet grouting was not activated. Okay, just allow me a moment. Now, I think everyone can see here in the bottom this particular error, failed to converge in nonlinear analysis. So this divergence can be due to a multitude of reasons, not necessarily a divergence should be due to load or anything else. It can be due to meshing, it can be due to plasticity. So the regions are quite big, but in this particular model, it can be identified to one thing only. You can see in while in the T4 part, this is being reached. So T4, if you start from this part, it will be this particular mesh. Okay, so this is where the model diverged. So we will see now, first of all, the impact of presence of the building there, and then until the model reaches divergence. Go to results. In the ground stage or the initial stage, we'll only go for the ground stresses, the vertical stress, horizontal stresses. and then the pour pressure. In the foundation stage, we activate the cushion, the raft, and the piles. So, due to the self weight, the deformation is around 6 mm. Okay, the actual load on the piles due to the combined weight of the solid of the raft and the cushion is around max 400 kilonewtons. I'll hide the water level. Okay, then the bending moments. So if you always have a doubt about if your model or the nodes are connected or not, you need to double check that with your results. So here we know for a fact the nodes are connected. That is solely by the virtue of the fact that the load transfer node is where the highest bending moment or highest axial load was being seen. That means on the top, which essentially means that the raft is effectively transferring the load to the piles. Now we go for the tower displacement due to the tower construction. You see, these are plates in here, shell elements, so they have more weight than this particular part. So you can see if I activate the vectors, how the building moves. Okay, here vertical, the vertical translation is around 66 mm in this part. So now you are getting a brief idea of why jet grouting is needed. If, let's say, hypothetically, this heavier side of the apartment complex was on this part, maybe we would not have required that. But since it is here, it's a very big chance that yes, that is why we needed the grout in there to protect the soil in between. So for the raft, if we want to see the forces, I'll just hide the cushion for now. Okay, my raft. Then the bending moments, shear force, then the plastic status. This is what we have to see first. So due to the presence of the building and all the load applied, you can see a large number of plasticity accumulated quite close to the vicinity of the building. Now, our goal should be that while on the long run, this plasticity will be slowly taken up by the surrounding soil and the stresses will be dissipated. If not, then we are looking at either soil failure or a building collapse due to foundation based failure or maybe punching failure. So, this is something that has to be kept in mind. So when I go to the first stage of tunneling and look exactly for the plastic status, you can see some of the soil is going back to its original form, but not the ones below the foundation or the highly stressed areas. So next, for T2, if you look at the total displacement deformations, And if I go to the cutting plane area, change it to Y. Okay, you can see how this area is affected due to the progression of tunneling. Okay, like this. Similarly, if I go and check out the shear zones, you can see a big shear zone forming along the vicinity between the residential complex and the tunnel. And finally, the stage where the last convergence took place, this is still remaining intact, right? This is not going away anywhere. This has to come down, otherwise we'll expect a failure. So if I just go for plastic status in this particular stage, you can see our tunnel face collapse. Because the surrounding soil is already under so much stress due to the presence of the apartment that the soil will not be able to take up any extra load, which is why the jet grouting was needed. Now we will see the results of what happens after jet grouting is activated. So I'll just show you the model where I have done the jet grouting, and it had been activated. You can see the model ran through the complete 24 stages. Let's say for random check, I just check on the ground deformation due to this. And this is only for the grouted area and the tunnel progression. If I activate all the mesh and just hide the water level, you can see. Okay. Similarly, if we just go for the cutting planes, total translation. So next we'll see the loads on the beam elements. I'll just hide the tower. Just look at the piles. Okay. Like this. With the seek bar, you can see the loads changing on the piles. Similarly, the bending moments in kilonewton meters. And in soil, the plastic status, if you see, it will be reduced to a very lower level now. So due to the presence of the grout curtain here, we can see there is no progression of plasticity from tunnel face towards the residential areas. Most of the plasticity has been contained inside the tunnel elements itself. Similarly, if you want to see the forces on the liners, just hide everything and go to liners. Okay, results. Let's say I want to go for the shell element forces. The YY is the hoop stress. deformed, undeformed. Just go to the front view. Okay, undeformed. If I go to the value option, you can see. So the reason being this part, the load is taken up by the some of the load has been dissipated due to the presence of the high strength grouted area, but not in here. Similarly, bending moments. So now you know the how the presence of one small ground improvement area drastically changes the results of your numerical modeling. So thank you very much, and I wish you all the best for your projects, and I wish you all the happiness for your future lives. Thank you very much. Goodbye.